Hi, my name is Johan Hinao, and the theme of my presentation is Artificial Intelligence Singularity. The topics that I will be discussing in this presentation are: what is the artificial intelligence singularity, Moore's law, the intelligence explosion, success and setbacks of AI, ethical analysis, and conclusion. Artificial intelligence singularity is a fascinating subject filled with imagination and skepticism. What is the AI singularity? According to Singularity.org, technological singularity has three distinct ideas: the intelligence explosion, the event horizon, and the accelerating change. The intelligence explosion refers to the idea where humanity builds machines with greater than human intelligence. This could potentially make the future unlike anything that came before it. Examples of such future are movies like The Terminator, The Matrix, and AI by Steven Spielberg. The accelerating change is based on the notion that technological progress feeds on itself. Each new technological advancement iteration is faster compared to the previous one. The event horizon is a situation where technology creates entirely new kinds of intelligence that will cause the future to be stranger than anything we can imagine. I've dedicated a few slides to talk about Moore's law, since I think that this is an important data point that will help us imagine the possibilities of a not too distant singularity. Intel's co-founder Gordon Moore predicted in the 1970s that the number of transistors on a computer would double approximately every 2 years. This law has persisted since that time. The ENIAC, numerical integrator and calculator computer built in 1945, filled a 20 by 40 foot room, weighed 30 tons, and used about 18,000 vacuum tube transistors. Today, the Intel Xeon processor MPX7460 has about 1.9 billion transistors and fits in the palm of our hands. Let us analyze this picture for a moment. If the transistors in the microprocessor were represented by people, the following timeline gives an idea of the pace of Moore's law. In the 1970s, the Intel 4004 was using about 2,300 transistors. If we continue to imagine that those transistors were people, we would need an average music hall to fit them in. By the late 1980s, the Intel 286 was using about 134,000 transistors. If those were people, we would need a large stadium to fit them there. By the year 2000, the Pentium 3 came out and was using about 32 million transistors. This is roughly the population of Tokyo. In 2011, the Core i7 Extreme Edition, which uses 1.3 billion transistors, came out. This is the total population of China. Now imagine that number of people squeezed in the small music hall that we mentioned previously. That's the scale of Moore's law. Let's keep in mind that the number of transistors is directly related to the processing power of a computer. Here's another chart that illustrates the trend of Moore's law. For over 40 years, that law has been sustained. We've gone from computers with 2,300 transistors to computers with about 2 billion transistors. With the advent of parallel computing and multi-core processors, this trend is likely to go on. In a nutshell, here we can see the strides that transistor technology has made over the past 40 years. An intelligence explosion will come at the moment we can build an intelligent technological entity. A feed AI is a computer-based artificial intelligent unit with the intelligence comparable to that of a human being. This intelligent entity will have the ability to self-improve. If we say that this AI seed has the IQ of 100, which is the IQ of an average human being, then 2 years after this AI seed is created, this AI seed will have an IQ of 200 based on Moore's law. If we follow this trend in 10 years, this AI seed will have an IQ of 3,200. The highest IQ of a person ever recorded has been 228. From the conception of the idea of the Turing machine by Alan Turing, artificial intelligence has come a long way. Turing said that the moment a computer could not be distinguished from a person based on written replies to questions, it should be considered to be thinking. Artificial intelligence has had significant achievements such as the invention of the Deep Blue supercomputer built by IBM, which was able to beat Russian chess master Kasparov. NASA successfully sent 2 rovers to Mars to explore the planet and send us pictures and soil analysis. GPS systems have been invented to help guide our way. Robotic surgery allows doctors to make more precise surgical procedures with a much lower error rate. Despite the achievements of AI still has great challenges ahead, and the goal of reaching human-like intelligence is not anywhere close. Two different branches working toward the same goal, connectionism and computationalism, have some serious challenges. Connectionism focuses in modeling the brain. The latest estimates are that the human brain contains about 30 million neurons and 1,000 trillion synapses, which are connections between neurons. The nervous system of a worm consists of about 300 neurons and 7,000 synapses, but no one has been successful in creating a computer model of this nervous system. Computationalism is the idea that a physical simple system has the necessary and sufficient means for general intelligent action. The assumption behind computationalism is that we can achieve AI without having to simulate the brain. The challenge with this approach is that in human experience, syntax and semantics greatly vary depending on the context. To give a simple example, day sometimes means day and night, and sometimes means day as opposed to night. From an Aristotelian point of view, we can see the AI singularity as a well-intended action. We are constantly looking for ways to better in ourselves. Achieving an AI singularity may give us an extraordinary advantage. Biological cognitive enhancements can help us achieve greater than human intelligence. There may be genes or molecules that can be modified to improve general intelligence. Researchers have already done this in mice. They overexpress the NR2B gene, which improved those mice's memory beyond that of any other mice. Biological cognitive enhancements in humans may cause the singularity to occur more quickly than it would otherwise. Once we reach a greater than human intelligence, we could reach the technology to enhance ourselves in every way possible and become a perfect society, since our self-destructive mind flows could be corrected. We could also reach the technology and medical knowledge to be disease-free and thus live forever. Space exploration for humans could become a reality, since aging would no longer be a concern. A counter-argument to all these well-intended ideas would be that once we design an entity with intelligence that is greater than human, that new entity will become aware and continue to better itself at an exponential rate. Shortly after, it will attempt to annihilate humanity, as we will no longer be needed and have become obsolete. An illustration of this scenario is the movie Terminator. It is far more common to hear people talk about the failures of AI and all the promises it never fulfilled, rather than to hear about the successes of AI and how important its integration into our everyday life is going to be. There have been significant achievements, and also AI continues to deal with great challenges ahead. It is certain that technology is progressing at an exponential rate. The idea of a singularity each day that passes by becomes a more tangible idea. Society needs to take the necessary measures to ensure that an AI singularity will not cause adverse effects to humanity as we know it. Our frantic desire to understand and know everything there is to know can lead us to disaster. We could be opening a Pandora's box that we may not be able to close back.